who are we at Alpha Publishing? We are a group of former educators who have come together to publish high quality ELT, math, science, reading, and literature, full courses, books, and online resources, but specifically aligning to international standards for the various regions that we serve. So we're not a publisher based in the US for the US. We align to international standards for this region. Okay. Now our current regions are Middle East, Africa, Latin America, and Asia. So again, hello to all of you around the world. And as Bev said, my name is Aaron Ashworth. I'm the head of US and UK publishing. All right, so next up, today's webinar, we're going to be talking about, as promised, flying pumpkins and quadratic equations. We want to be able to teach math online and also make it fun. We're going to be using simulations today to do that. Now, we're going to switch it up a little bit and infuse some science into math today, so we can focus on what we're considering a cross-curricular experience. Now, first we're going to bring STEAM, and I'll talk about STEAM in a moment, into the math classroom. We are going to talk about multiple intelligences so that we can reach every student. I want you all to pretend that you're students today, taking this from their perspective as we go through the simulation. We're going to be modeling math using real-world phenomena, and I'll go through that in a sec. That's a mouthful. And we're also going to have fun with virtual investigations of quadratic functions. At the end of our session together, I'm going to do a quick review of our grades 6 through 8 math program for those of you who are new to Alpha Publishing. And then we'll stop for some question and answers. So if you do have questions, Bev, if it's okay, if you can write your questions in the chat, and I think, Bev, you'll keep track of those until the end. Is that correct?
Yes. Yeah.
Great. Thank you. Okie doke. All right. So STEAM. Now, we only have 40 minutes. Otherwise, I would actually stop and ask questions and let you unmute yourselves and tell me what the STEAM means. But because we have limited time, I'm just going to go through this. So S is science, T is technology, E is engineering, A is art, M is math. Now, we're here for math, so why is the M at the end of STEAM? It doesn't have to be. Okay, so let's switch it up. Meat. Now, some of you like meat, like me. Some of you are meat eaters. Some of you like vegetables if you're vegetarian, and that's fine. But today we're going to talk about meat because M can come first. We're going to discuss math in context of engineering, art, technology, and science. Next, we want to be aware of the multiple intelligences of our students. As we're going through this simulation, you'll see today that we don't hit all 8 of these multiple intelligences. These are based on Howard Gardner's theory of multiple intelligences. Today we'll be focusing on 4 of them, and that's okay. It's very difficult to hit all 8 intelligences in one activity. Today we're going to be focusing on visual spatial. Most students out there are visually oriented, so the simulation today is going to be highly visual. We're going to focus on logical mathematical. Today we're going to be collecting data, and we're going to be using equations. Now, interpersonal and intrapersonal depends on how you break up your classroom. If you have quiet time and students are working by themselves on this, and they're reflecting and answering questions, then this might gravitate towards intrapersonal, like me, those who like to work by themselves and then come together and discuss. Or if you structure it as group work and have students discussing and explaining as they're going through this, it might gravitate towards interpersonal, for those of you who like to discuss things first as your way of understanding. Okay, let's begin. So what we want to do is anchor ourselves into this learning experience. Some of you may recognize this icon from the anchor activities from grade 6, 7, and 8 math. That's great. Now we're going to consider this as an anchor activity for quadratic equations. We're not going to go fully quadratic today, but we're gonna tease the quadratic equation into the classroom. All right, let's start with vocabulary. A very good place to start. This vocab card is from page 557 of our Alpha Math Grade 8 Volume B book. And I'll discuss how important vocabulary is at the end of our time together. Quadratic equation is a polynomial equation in which the highest power of the variable is 2. Quadratic equations can be written in the standard form ax squared plus bx plus c equals 0. Remember, ax squared plus bx plus c equals 0, because we'll see that equation again later in a different form. If any of you mathematicians out there have studied physics, you know where I'm going with this. All right, so you may have heard the story of Isaac Newton sitting under the tree, and an apple fell and bonked his head, which got him thinking. Now, nobody really knows if the apple actually did hit him in the head, but that's okay. Let's pretend, for the sake of our story today, that it did. So Newton came up with his theory of universal gravitation when the apple fell down from the tree towards the earth and hit him in the head. Now he got to thinking, this is an observable thing. I'm seeing an apple fall from a height to the ground. So phenomenon in science are basically just occurrences in the world that can be observed. All right. So Newton made some observations here, and some of the things we're going to discuss today, which resulted from his theory of gravitation, is the acceleration due to gravity. We're going to be considering height. So the apple had to fall from some height and result in a lower height. Velocity. If the velocity was 0 when the apple hit his head, he would not have felt it. So there must be some velocity that the apple has when it hits Newton's head. And it takes some time for the apple to fall down. Okay, now again, I'm going through this very quickly, but with your students, I would recommend slowing down and have them looking at this picture for a little bit and ask questions to tease out some of these variables that we have over here. All right, so now, I'm getting some feedback. Okay, so now we're going to go to EAlpha. I'm going to go fairly quickly through this, again, because we have limited time, but I'm going to give you maybe a minute to set yourselves up. If you already have an EAlpha account, go ahead and log into that now. If you don't have access to the internet on a laptop or something with a large screen, don't worry, because you'll be watching me use the simulation on my screen, so you don't necessarily have to follow along. But I'll give you a minute now. If you go to www.ealpha.info. You can use this login information, trial, capital M, capital S, period teacher, lowercase t, and the password is capital M, capital S, hashtag 123. Okay, so go ahead and write that down. Bev, would you mind writing that in the chat? Actually, I can put it in there right now. Okay, so our login is Bev, for some reason it's not letting me type. Would you mind putting it in there?
Sorry, yeah, I'll just do it.
Oh, thanks, Samar. Great. Samar, you're a rock star. Okay, So once you log in, once you go to ealpha.info, you'll see this screen. Go ahead and click on login in the upper right-hand corner and enter the login, which is trialms.teacher, and the password. Apologies, I'm going to keep going through these steps fairly quickly. Once you hit login, it'll take you to the next screen where you see your dashboard. Welcome to EAlpha Dashboard. Here are the steps you need to take. Number 1, hover your mouse over UFK12. Don't click, just hover. Hover your mouse over UFK12, over here on the left. Then move your mouse carefully over to the next screen and go down to Alpha Math. Just hover, don't click. And then move your mouse carefully over to the next screen and go all the way down to Alpha Sims, next to the number 3. Okay, so again, we're clicking on USK12. We're hovering over to Alpha Math, and then hovering again down to Alpha Sims. All right, once you get to Alpha Sims, you'll see that we have a lot of sims for science and math, but let's narrow it down. Go ahead and in the search box, type in the word projectile, and one simulation will come up called projectile motion under math sims. Okay, while you're doing that, I'll point out that for all of our sims, we have a grade band. So this one can be used anywhere from elementary school to university, depending on how you use it. Today, we're going to be focusing on upper middle school to lower high school concepts of algebra. This can be used for physics and math. And here are all the main topics that are covered by this simulation. Today, we're going to be talking about parabolic curves at the end of our time together, and also projectiles. If you see over here under support documentation, you have a video screen and a light bulb. The video screen, if you click on that, it's a how-to video for the simulation. So if you haven't used the sim and you're using it for the first time, not now, but in the future, you can click on that and it will guide you through the simulation. If you click on the light bulb, it will take you to teacher resources, which include worksheets that you can use with great questions for your students. Okay, next slide. Once you click on that simulation, you'll be taken to the home screen where the simulation will begin. Now, you have a few options here. We're just going to do the intro simulation today. We're going to keep it simple. All right, so once you see this screen, go ahead and click on intro.
Sorry, Bob. Can you repeat the previous part?
Sure.
I didn't get it all.
How far back?
I'm so sorry for interruption. Yeah, this one. What the
so
cards?
In the search box, type
where
in
I can find the
projectile.
cards?
Sorry?
Where I can find the cards, the worksheets.
Ah, the worksheets. Okay, over here under support documentation. Now, we don't need to use these today. I'm just giving you this for future reference. So don't worry about this right now. You can click on the light bulb and that will take you to teacher resources, which has the worksheets, okay?
Okay, thanks.
All right. Sorry?
Thanks a lot, thanks.
Yep, sure. All right. So once you click on intro, it will take you to this screen, and this is the simulation that we're going to be using today. Now I'm going to switch out of the PowerPoint to the live simulation. Again, if your computer is not working, or the internet is not working, or your mobile device is too small, don't worry. You can follow along on my screen, and I'll help you collect the data. All right, one moment. I'm going to unshare my screen and reshare the simulation. Whoops. Can everybody see my screen?
Yes, sure we can.
Oh, there we go. Okay. All right. So here we have a bunch of fun things that we can do. Now, there are a lot of options in this simulation, and this is why it can help you range from upper elementary school all the way into university, depending on how you use it. Today is going to be fairly simple, so we're going to ignore everything over here on the right, except for pumpkin at the top. I did promise you that we were going to be launching pumpkins today. Now, if you want to, you can launch a whole host of different other things, including pianos and cars, but today we're not going to be launching pianos. We're going to be launching pumpkins. All right. Over here on the left, you see we have a cannon. We have speed. So, for example, let's go ahead and just launch the pumpkin. So the pumpkin now is traveling at 15 meters per second. I can increase the speed. I can decrease the speed. I can even change the height. So I can go up and down with the cannon. So here maybe I want it to be 0 meters above the ground. Maybe I want the pumpkin to launch 15 meters above the ground. Okay, let's keep it at 10. All right. If you want to clear the screen, you can either go to erase, which erases the pathway, or the reset button in the bottom right-hand corner to reset everything back to original. Okay, today we're only going to be using the following buttons. I want you all, if you're using the simulation, to first click on slow at the very bottom. So click on the word slow. We want to view the pumpkin's trajectory very slowly, otherwise it'll be too fast. Okay, we're going to be using the pause button, the fire button, the erase button. We can leave the speed alone for now. And you want to have your cannon at 0 degrees. Okay, ignore the statue of David. I don't know why he's there, but we'll just ignore him for now. Okay, now up here you see we have some measuring tools. Here's a measuring tape for measuring distance. We want this one. So go ahead and click on it and pull it out of that box, and you can just drop it anywhere on your screen. You see here, this measuring tool can help us measure time, range, which would be change in position or change in distance, and height. So range would be change in position in the horizontal direction, and height is change in position in the vertical direction. Now, this lab would be a lot easier if we were shooting projectiles vertically. However, it's difficult to see on this simulation, so we're going to be shooting projectiles horizontally. However, we're only going to be considering the vertical position of the object. All right? So, if you go ahead and fire the pumpkin, you can use this device to measure at each of these little points that you can see along the line, what is the time. So if the pumpkin is fired with an initial speed of 15 meters per second, how long does it take to reach this point? It takes 0.7 seconds. At 0.7 seconds, it has a height of 7.6 meters above the ground. Okay? Now, if I was doing this with students before I actually started to collect data, and we're not going to do this because we don't have enough time, what I would do is ask them questions. For example, students, what happens, or what would you predict would happen if I increase the initial speed? And then I would ask them to make some predictions and test it. So if you increase the initial speed, you see that the horizontal distance changes. What about the vertical distance? It's still 10 meters to the ground regardless of what your initial speed is. Okay, let's go ahead and reduce the speed, see what happens. You could play around with angles with them and just have fun and let them observe and see what happens. Now, for purposes of today's simulation, we're going to be looking at height and we're going to be looking at time. Okay? So we're going to be looking at height and time. If you have a piece of paper and a pencil in front of you, or if you don't, go get one. I'll give you 30 or so seconds. And we're going to be measuring height and time, and recording heights and time. So let's make it easy and reduce the speed to 10. So in the bottom left-hand corner, go ahead and reduce your speed to 10 meters per second. All right, and then go ahead and launch your cannon. Oh, look at that, I got 2 stars. Okay, again, if you don't have the screen up, that's fine, because we're going to be using my screen now to collect data. If you have your simulation running, then you can use your own to collect data. So again, set your initial speed at 10, go ahead and fire the cannon, and then stop. We don't need to do anything else now. With your pencil and paper, or pen and paper, I want you to make a T-chart and put height in the Y column and time in the X column. So I'll show you what I mean. So go ahead and make a T-chart like this with height and time. Okay, now what we want to do is collect some data. I want to start at time equals 0. So at time equals 0, go ahead and record the height. So in the right-hand, on the right-hand side, I'm writing 0 for time. On the left-hand side, I'm writing 10 meters for height. And what we're going to do now is record time and height for every single one of these points on the way down. And then we're going to graph it. Okay, so here we go. I'm going to go very slowly. So this is the first point. Go ahead and write down the time and the height. Height goes in the left-hand column, time goes in the right-hand column. Next point. Actually, let's make this go a little bit quicker. We'll go every other point. Okay, so time 0.2 seconds, we have a height of 9.8 meters. Let's go to the next one. At 0.4 seconds, our height is 9.22 meters. We'll go to the next one. At 0.6 seconds, our height is 8.23 meters. Next, 0.8 seconds, our height is 6.86 meters. Next one, at 1 second, our height is 5.1 meters. Hello there. Next point, 1.2 seconds, height is 2.94 meters. And the last one before the pumpkin goes bust, at 1.4 seconds, the height is 0.39 meters. Okay, I have the chat open, so in the next 30 seconds, if anybody needs me to go back to get any of these data points, let me know. Okay, great. Right, so what I want you to do now is go ahead and set up a graph. Go ahead and set up a graph on your page. Okay. Now, if the students in your classrooms are using graphing calculators, they can certainly go and use the graphing calculators to collect their data and form a graph. but we're just going to use good old-fashioned hand drawing today to draw our graph. So set up your y and x axis and label the y-axis with height and the x-axis with time. Yep, I see some ideas here. You could certainly convert it into an Excel sheet, and Excel can give you a great scatter plot. The other, if you do teach physics, you can use Logger Pro. Let's see, Jalal says you use the TI Inspire technology. That's great. Casio also has great technology for this. Okay, once you set up your graph, go ahead and graph all of these points. And then in about a minute, I'm going to ask somebody to show us their graph. I think maybe I'll pick on one of my editors.
Your editors are watching and making breakfast right now.
Okay, I know it's too early for you there. So my math editors today are joining us from the United States in Ohio. So that, yes, it's very early for them and they are making breakfast. I think it's 7:30 a.m. for you right now. Let's see who else I could pick on. I could pick on Danielle Nasser, our head of training and consultancy. I could pick on some of our business development executives, maybe Iqbal, Zainab, Eliza, Samar, Tala. Islam. All right.
Yes, I'm here. I'm here.
Who would like to show us their graph in the chat? The first person who wants to show us their graph wins. Just in the chat box. If you don't know how to get to the chat box, go down to the controls for Zoom. Click on the More button and open the chat. Nobody? Is everybody making breakfast?
No, we need more time.
You need more time? Okay, great. That's fine. I can give you one more minute. So some questions that you could be asking the students as they're graphing this is about the relationship between height and time. So I might ask questions like, as time increases, what happens to the height? Does height increase or does height decrease? So let me ask that question as you all are finishing your graphs. What happens as time increases? Tell me what happens to the height. Does it increase or decrease?
Decrease.
Decrease, of course.
Correct. Height decreases. Now, is it decreasing the same way as you go through time? As time increases, is height decreasing at the same amount? Okay. Isan said no. Tala says no. So,
No.
when time is close to 0, how much is the height changing? Is it changing more or less than what it is towards the end of the trip? Anyone? Is there a greater change in height at the beginning of the trip or at the end of the trip? Okay, more towards the end. Great. Yeah, so what we need to start doing, and this is starting to get into quadratic functions and parabolic motion, is as time increases, your height is decreasing, but it's decreasing at an increasing rate. Okay, this is an exponential function. So this is getting into the mathematics of it. I told you this is a little bit of a scientific teaser for this. And this is a great model to get students to visualize projectile motion, parabolic motion, or curve functions. Okay, is anybody ready to show us their graph? Go ahead in the chat. Go ahead and write. Anybody? Anybody? Nobody? Okay, Mai, Abbas, and Jordan said the graph will be a parabola. Okay, it will be a parabola. Now let's use some math terms. Will the parabola be concave down or concave up?
Down.
Right, concave down. So this is my really rudimentary graph that I just drew, and I didn't actually plot the points, but does your graph look like this? Yes. Okay, great. Okay, so the students will see that their graph is moving in a parabolic way, and as time increases, height is decreasing at an increasing rate. Right, now we are out of time for the simulation. There are a whole host of different things you could do with this. This again is just a teaser. Let me unshare my screen and I'm going to go back to the PowerPoint. One moment, please. Whoops. There we go. Okie doke. So I asked you to remember the equation, the quadratic equation, 0 equals ax squared plus bx plus c. And here we can see that if we start to replace the variables a, x, b, and c with the equation for vertical motion, we know that we can see that y is height, a is our acceleration due to gravity, or g, t is time, b is the initial velocity, and c is the initial height. Okay, I'm going through this very quickly, but what you could do is have the students go back using the equation now, the equation for motion, that involves acceleration, and actually start solving for some of these variables using the simulation. Further extensions for differentiation, if you have students who are advanced, or if you are have a class that's in high school, you could use the equations for parabolic motion, and you could change the angle of the cannon, keep it fixed, and calculate the time that the pumpkin stays in the air throughout the whole trip, both when it's going up in height and when it's going down. You could calculate the maximum height and a bunch of other things. Basically, any of the variables that you have in that equation, you could ask the children to solve for, the students to solve for. In our book, in Alpha Math, we have some great features. For example, this one, which is in Grade 8, Chapter 14, Quadratic Equations, Lesson 1, Solve Quadratic Equations by Graphing. We have some great activities like Math Around Us, which relates quadratic equations and parabolic functions to math around us. For example, this is an example of football and kicking a football. And of course, this is an ideal situation where the football would travel in a parabolic path. But we start to ask questions about quadratic equations by linking it to math around us, around the world. Okay, so let's transition now into a brief review of Alpha Math grades 6 through 8. I showed you a little snippet of it before about the math around us, but let's talk about what the program is. Now, if you're teaching this, that's great. This will be a review, but if you don't know anything about middle school math, I hope you learn a little bit about it. So we have 3 grades, grades 6, 7, and 8. Each grade has 2 volumes, volume A, volume B. And we have chosen cover artwork to reflect most of the countries, most of the regions in the world in which our students reside. We have grade 6, we have grade 7, grade 8. All right, so what is Alpha Math? Again, we have aligned our program tightly to the Common Core State Standards. So all the lesson objective and essential questions have come directly from the Common Core State Standards. It's very important that we start with those and build our content on top of that. So while it's based on the US Common Core State Standards, it is specifically written for global use, and originally for the Middle East. So we do have a presence for each country in our region in our book. We have step-by-step, easy to follow instruction in the teacher guide. The lesson cycle is very easy to follow. We have differentiated instruction, especially in the UAE where it's mandated. I don't know if it's mandated in your countries, but it is really important to try and differentiate. And we give you 2 ways to do that. One is by differentiated practice books, reteach for students who need a little bit of help, and enrich for those students who can handle a challenge. And I'll talk about our anchor and exit activities later. Our anchor activities are also differentiated. Alpha Math takes a cross-curricular approach. We're constantly talking about other fields in education. We're linking math to reading, we're linking math to science, we're linking math to technology, to careers. I'll talk about that a little bit later. We have interactive online and offline resources on our content learning management system, EAlpha. And of course, this program promotes the 21st century learning skills. Okay, we have the standard student book and practice book. The student book is where the students will do their learning and they're guided by the teacher. And the practice book supplements each of the lessons with on-level review questions and extension questions. We have the teacher's guide, of course, which contains the student book and also teacher instruction, which is wrapped around the outside. We have 2 differentiated practice books. Our digital resources include our anchor activities and our exit activities. So these are on EAlpha as downloadable or interactive activities. The anchor activities are differentiated. I'll show you those in a moment. Now, coming very, very soon is our digital assessment bank. We have partnered with Learnosity and are in our very final stages of going live with this on EAlpha, our content learning management system. So this will be, I'm sure, blasted to you through our marketing channels once it's ready, and we will have some fantastic trainings for you when that happens. In fact, Kelly Bergheimer, who is one of our math editors on the call, will be helping you with that. We also have lesson plans, and our lesson plans are downloadable. They are Word documents, and 100% editable, so you can customize these around your needs. We have video clips. Now, we have video clips for math and science that have kind of hit different ranges, and you can use these to help start the lesson. Okay, let's start with planning. At the beginning of our books, we have our scope and sequence. This gives you a big picture overview of what the books are going to take you through from chapter 1 at the beginning of the year through chapter 17. In the scope and sequence, we give you the chapter title, the lesson title, the strand of Common Core. So this is geometry that we're looking at now. It gives you the Common Core state standards that are covered in that lesson, the mathematical practices that are covered in that lesson. It looks back at what you would have covered before this, and it looks ahead at where this will be covered next. Once you get into the chapter in the student book, you'll see, again, all of the lesson titles. You'll also see the essential questions, which are taken from the Common Core standards. And the essential questions will be answered by the end of each lesson. Here again, you see the look back across the grades for Common Core state standards, what will be in this chapter, and what will be next. Okay, for each chapter, we then list the Common Core state standards verbatim. This is directly from the Common Core state standards. We have not created these. And then a reminder from the scope and sequence, the objectives, the essential question, the state standards again, and the mathematical practices, and any vocabulary. This is a snapshot of the lesson plan. Now, you might think at a glance that it looks fairly simple, but that is by design. It's simple so that you can edit it. We didn't want to put fancy design or heavy design on it, so it's a very light document. It's easy to download and easy to edit. Okay, so it takes you through the chapter and the lesson cycle and brings in all the different components that we talked about earlier, such as anchor activities and exit activities. Vocabulary at the beginning of the chapter, we wanted to spend a lot of time and care with vocabulary, especially knowing that even in grade 6, sometimes 7 and 8, if students are transferring in from government schools or anywhere really, maybe they're homeschooled, it might be difficult for them to grasp some of these words in English. So we wanted to spend some time giving them the word, the definition, and a visual representation of the vocabulary. Okay, so you see here you have the word additive inverse. It gives you the definition, and then it shows a mathematical sentence that explains the vocabulary word. Okay, we also have special features throughout this, and there are a few of them that I really want to show you. Again, we really want to help English language learners so that the English never gets in the way of the math. You can see here that we're talking here about number lines and negative and positive. So this English language learners tip helps students to categorize positive numbers like above, up, and profit, and negative numbers, negative words, words that connotate negative numbers like below, down, and loss. And so this helps the English language learners to categorize words into what they connotate in terms of what they're learning. All right, at the lesson level, we have our starting points, and chapter level, we have our starting point. So this takes students step by step through what they're going to learn in the upcoming lessons. We have teaching tips. One thing I wanted to point out, and I don't have time to take you through the whole lesson cycle, but I really wanted to focus on the examples today because I don't know, when I was learning math, I felt that the examples were very frustrating. Sometimes I felt they didn't really exemplify what I was about to practice when I was doing homework problems. But our examples are fantastic. They give the students a lot of visual cues and explanations and tips as they're going through. Again, Math Around Us is a great feature because it really connects the math students are learning to anything from science concepts here to, for example, we're talking about how much water a camel can drink in 7 minutes. Now we're linking it to technology. Here we have chemistry and molecules. Back to life science. And now we have stats and temperatures around the world. Back to differentiation, we do have anchor activities that will, it's a quick and easy, fun way to begin the lesson. And there are 3 anchor activities per lesson. We have an on level for students who are fine with the lesson, on level for students who have not been struggling, and this will be a quick and fun way to introduce the lesson for them. Then we have up here in the upper right-hand corner our indicator, which shows you the level of differentiation. We don't want to label these sheets or students with any words, so we put these icons here for teachers to use. If the ball is in the middle of the little track here, that means that the anchor activity is on level. Next, we have the ball on the left. That means this is reteach. So this anchor activity might be given to a student who has been struggling and needs a little simpler of an activity, something that might maybe review some prior knowledge or help them in a more step-by-step fashion before the lesson begins. Next, we have the enrich activity when the ball is on the right. This is for students who can handle more of a challenge. So this matching game where they cut out each card and turn them face over is in 3 different degrees of difficulty, or let's say can serve 3 different purposes when it comes to intervention. Okay, now we have cross-curricular connections. We have math features that connect to engineering, math and science, math and arts, math and English language arts, careers, timelines, ESL and English language learners activities, study tips, and test-taking strategies. Okay, and finally, at the end of the lesson, after our closure, we have an exit activity. And exit activities are very quick, formative. You could use them as a formative assessment, or it's a quick snapshot of where students are. Did they understand what they learned in the lesson? And this is a great way to gauge their understanding before they go into the assessments. We have a reflection, which goes back over any concepts and maybe any vocabulary that was in the chapter. And then we want to check their understanding with problems and questions. These problems represent problem types from each one of the lessons in the chapter. Okay, and then we have a reflection check, which helps them to check their responses to that. In the practice books, we have mid-chapter quizzes, and we have a multiple choice quiz. And then at the end of the chapter, we have a chapter test. All right, I think that's about it. Thank you so much for joining us. Again, any questions about your account, please email your account's executive. And I appreciate the time with you. Thanks for joining, everybody. It's good to see some friendly faces again. And have a great day.